Maybe he was that guy who's doing stuff in these locked doors.
Welcome to ECE 320A, exam number 3 review. You may be seeing this or watching this while you're trying to get to sleep. Hopefully that will help you get to sleep. But quickly, the process is what we said today in class. 3 sheets of notes is really the only difference between the previous exam. Material is homework 6, 7, and 8, and the topic, there is a list on D2L, and there's also review material. This is maybe a little bit more detailed than what we talked about in class today, but the Laplace transform, you need to be able to do S-domain circuit analysis, which incorporates initial conditions, and there you need to know the distinction. If I say in the problem statement, include sources that will make your analysis more like mesh analysis or more conducive to mesh analysis, hint, hint, that means I want you to include the series voltage source initial conditions. Is that clear? Or if I say you're actually going to maybe do KCL or node voltage analysis, then you will want to include your initial conditions as parallel current sources. That's what I'm meaning by know those two options. And if I don't say, then it's really up to you to decide how do I want to incorporate my initial conditions into this S-domain circuit. You also should be able to find transfer functions from a circuit, and what I'm meaning by matrix expressions, can you put the equations in a matrix form? Let's say you have 3 mesh equations. Can you make the impedance matrix have some combination of S variables or some expression in terms of these impedance values on resistors, inductors, and capacitors? That's what I'm meaning by the matrix expressions. You should be able to come up with some general expression that looks like Zi is equal to V, where if you had 3 different meshes, I is now this I1 of S, I sub 2 of S, and I sub 3 of S. That's what I'm meaning. And Z now is some square matrix that has 9 entries in it, and you need to be able to populate those 9 entries in that 3 by 3 Z matrix. If I had 3 currents, if you had 3 meshes in your circuit. I hope that makes sense. That's what I'm meaning by matrix expressions. Convolution. I might break this down, and you should look at the example exams to get an idea or a feel for what I might be asking. I might ask you for what interval of time is the output waveform going to be non-zero? When does it start? Let's say T start, and when does it finish? And that might be -7 to +6. Or it might be from T equal 2 to T equal 10. It's when is Y of T going to be non-zero given the input waveform and the impulse response, or the H of T waveform that you are convolving. Question?
Is that when there is overlap?
So that would be when there is overlap, is when I'm asking, when do you have some overlap between H of T and X of T minus tau, for example? What did I just say? H of, let's say, tau and X of T minus tau. When is there overlap? For what values of time T does that happen? I could even ask you to flip and slide a waveform, or flip a waveform and include the T so that it could be slid from -infinity up to +infinity. I might ask you to give me the expression, the integral expressions between T equals 4 and T equals 20 on some convolution example that might have many, many more integral expressions than just between 4 and 20. But I may just ask you, give me some correct intervals and limits on those convolution integrals that would accurately define that output waveform without actually calculating the result. Just give me the expressions that includes the correct integrand and the correct limits on your convolution integral expression and when those convolution integral expressions are valid for what intervals of time, t. So the intervals on that y of t and the limits on your integral in that expression. Then I might even ask you, find the output y at a specific instant of time, t sub 0. T sub 0 might be 3. I might say, find y of 3, when it might be non-zero between -6 and 20. And now I'm just asking you to find the output value at one instant of time. Maybe that ends up being when it's 0. Then the last part, topic-wise, is sinusoidal steady-state response. I need you to feel very comfortable with finding h of j omega, either analytically or graphically. And I might ask you, for example, this illustration might be, tell me the phase contribution due to the pole in the third quadrant, or the pole at -3 minus j2. And now I'm just wanting you to find theta sub p1. I'm not asking you to find all of the different angles of the different poles and zeros of your overall transfer function.
When you say the contribution,
So now if the question, well, this is, I'm sort of pulling this halfway through the question, but you might have an h of s, let's say, that looked like s plus 1. Well, maybe I want to do something different. Let's say it's s plus 4, and this is now s plus 3 squared plus 2 squared. And now I might say, give me the phase contribution due to the pole in the third quadrant. Then you would have to realize that, oh, that quadratic in the denominator has two different factors, and I'm interested in, now I'm running out of space, I'm now wanting to think of h of s as s plus 3 minus j2, s plus 3 plus j2. This is s plus 4, and there could be even some scaling amount here. Let's say it's 25. If I say find the phase contribution for the pole in the third quadrant, which of those factors are you interested in? That's the one you want to look at, and now you will be saying, oh, what does that phase, or what's the angle of that factor? How is it contributing to h? In this case, it's actually going to be theta p1, but since it's in the denominator, if I say how does it contribute to h at j1, or at omega not equal to 1, you need to subtract that because it's in the denominator. I don't know if it was clear from earlier today, but if we are now looking at h of j omega naught for this particular expression, now we could say, oh, I have a length due to the zero factor at a given omega naught and its angle. and I have length due to, let's say, the pole in the second quadrant and its angle, and the length and the angle due to the pole factor in the third quadrant. But now, how do you use this? You multiply and divide the lengths, and that will give you the overall magnitude. But the angles, you now take all of the angles in the numerator and add those up and subtract all of the angles in the denominator. Is that clear? Because they're in the denominator. So that this now would be minus theta P1, and I keep wanting this to give me more, plus theta P sub 2, but that's all inside those parentheses so that I can now subtract off my pole angles. Is that clear? But if I ask what's the contribution due to this factor in terms of its phase, you would compute, you would say, okay, the phase due to that pole is theta P2, and that would be this inverse tangent. In this case, what's the vertical, or what's in the numerator of that inverse tangent expression? From minus 2 up to 3 is a delta of 3 vertically, and horizontally I'm also over 3. So that this, maybe that was a bad example, but this is the 3 in the vertical and 3 in the horizontal. So that is now this 45 degrees for theta sub P sub 2, but its contribution to H of J1, it's contributing a minus 45 because it's in the denominator, it was a pole factor. So that could be a little bit confusing, but you would get most of the points if you can identify that theta sub P sub 2 is 45 degrees. Because of the wording, it may not be real clear what's he mean by contribution. But that, if you were computing the angle of H of J1, you would have the angle due to the 0 and these two angles due to the poles. And you would algebraically combine those. All the zeros are in the numerator, you add those, and the denominator angles are subtracted algebraically. Questions on that? Yes? So now what we are just computing the angle for, let's say, theta sub P sub 1. Actually, I relabeled that, didn't I? That's what I was calling theta P sub 2, was I not? So why don't I change that? Is that okay? All I'm asking is the angle. I don't need to include that J because the J just says I'm going vertical, whatever is in the J direction, and I'm going horizontal in the real component. I just need that angle between the X and whatever omega naught I've specified, and in this example I picked an omega naught equal to 1 radian per second. So the J piece tells me what's my vertical, and that's in the numerator, so that's why I'm saying it wasn't a very good example. If I wanted to do this now at, let's say, omega naught equal to 3, I would be up here. And now if I wanted to know what is theta P sub 2 at omega naught equal to 3, that's now the inverse tangent of what? Now I'm looking at that as my angle. I now have to figure out what's my delta in the y at omega naught equal to 3. So I'm 3 above and 2 below, a net or a change of 5 in the vertical, and in the horizontal it's still 3, so that this would be the inverse tangent of 5 over 3. And that's bigger than 45. Is that clear, what I'm trying to communicate or talk about? Other questions? Yes. So now if I ask for the phase of h of j, you would have to combine all of those factors' angles. If I said, what's the phase of h at omega naught equal to 1, then you would have to find the phase of the 0 and the phase of those two poles and algebraically combine them in the direction that they needed to be combined. In this case, for that particular transfer function, I have a 0 there at -4, and I have another pole there. So that its angle, theta sub p sub 1, what's its angle? It's a negative angle, isn't it? And I would be subtracting that. It's a minus 1 divided by 3. So if I said, what's the angle of h of j1, that's now the theta sub z over theta p1 and theta p sub 2. This, what's the angle of theta sub z at omega naught equal to 1? How much am I going up vertically? 1 if I'm doing it at omega naught equal to 1. So this is now at j1. So this is now the inverse tangent of 1 over 4 theta sub p sub 1 inverse tangent of what? You could either say, well, I would say probably just to show it, I'm going down 1 and over 3. That's the angle for theta sub p sub 1. And this angle, so these are all angles, is what we had calculated, I think, before, isn't it? That's now the 3 over 3. And the phase, then, would be whatever this angle is, inverse tangent of 1/4. I don't have those inverse tangents memorized, but we know that it's less than 45. And you could eyeball it. Let's just say that it's approximately, oh, and my diagram isn't drawn very properly in terms of my units on the horizontal are not necessarily equal to the unit spacing in the vertical, but let's just say that it's, pardon? 14, I was going to say 10. So we now have 14 degrees minus, what's the inverse tangent of minus 1 over 3? Minus 18. Is that close enough? 0.43. And then we also have, this one was 45. That one I could do. So now if you algebraically sum those, you're adding 18 and 14, that's 32 roughly, and subtracting 45. So it's minus 13 roughly. Is that close enough? So that's now what you would have for the phase of h at omega naught equal to 1. You need to be very comfortable with that. I'm assuming you have that down. Are there questions on that?
Are there other questions like in that style that we just look at the previous exams, or have you not done that before?
I think I have done that before. So the question was, do previous exams have something like that? You're going to call me a liar now, but I think, so problem 9, for example, It says find or determine or compute the phase angle associated with the complex zero.
Correct.
So that one you wouldn't have to necessarily, that one is associated with. So that's different than the contribution. Do you get my distinction? So the zero, the association and contribution, it doesn't matter because it's always coming in at the same, with the same sign because it's in the numerator. But poles, if you ask for what's the angle associated with the pole, let's say at -1, you would just compute its angle. But if I said, what is the angle contributed by the pole to the transfer function at, then it would be the negative of that angle. Is that verbiage confusing enough? I'm not trying to trick you. I just want you to understand the distinction or the difference. Yes?
This will be post-processing.
You are, well, if you really want to listen to this again, you can listen to this again. Yes, so I was making a distinction between contribution and association. But I mainly want you to find the angle of the poles and the zeros. Yes? If it's unrelated, we're moving on. Oh, okay.
Not this part.
All right. Sure, go ahead.
When we're sketching the S-domain equivalent circuit,
Yes?
assuming mesh analysis, you want to put your sources in parallel. But if you're assuming nodal analysis, you want to put your...
So I think you just got it back. So now if you want, if in this particular example, it says, assume that we're doing nodal analysis. So now you put your sources as current sources in parallel. So now if you have initial conditions on C's and L's, then what you're looking for is you have two different ways of incorporating initial conditions due to these energy storage devices in an S-domain equivalent circuit. If you're doing it to perform nodal analysis, then you would be looking at parallel current sources for both the C's and the L's. If I said do this as if you were going to perform mesh analysis, then you would be wanting to put in series voltage sources for your energy storage elements in the circuit. Does that answer your question?
Yeah.
So that's, yes. So you need to know the distinction between those. If I say, assume you're doing nodal analysis or assume you're doing mesh analysis, you need to know what that is hinting you to do. Hint, hint. Okay?
Could you quickly write out the answer, or do you not?
Could I quickly? No, probably not, because I would have to, I can rederive it. So what I do is I go back as if I was in an interview, and I would say, oh, let me do this for the inductor, which is Eli, and that says that V sub L of t is L di sub L dt. I would Laplace transform that, and I now have, but you could put all of this, not the derivation, but on your cheat sheet, you now have L times S I sub L of S minus I sub L of 0 minus. And now I would say, oh, whoops, this is now an impedance piece, and it's an initial condition piece. And now my voltage, if up here I had labeled this as plus V sub L minus, now in my S-domain equivalent circuit, I would have an SL here, and how would I put the polarity in that voltage source? This is supposed to be V sub L of S, and it's made up of two pieces. So now over here, V sub L of S is actually all of this. And if you were to, let's say, do KVL around this, you might say, oh, there's minus, and then I'm going this direction. And in fact, my current is that current. That's I sub L of S. I'm running out of space between that and my... So if I did KVL here as a check, I would say, oh, that's minus V sub L of S plus SL I sub L of S, and I need to now say minus L I sub L of 0 minus equals 0, so I need this to be minus plus L I sub L of 0 minus in order to incorporate the initial condition consistent with what this expression told me. Meaning if I now solve this expression for V sub L of S, I have V sub L of S is equal to, just putting it on the other side, it's an impedance piece minus L I sub L of 0 minus. Is that clear? And if you were needing to do it for a nodal analysis, which I did it for a mesh right here. So this was for the mesh. If you needed it to be for the nodal analysis, you would solve that for I sub L and then incorporate the appropriate signs for a current source to incorporate your initial conditions. But you should do that before the exam so that you know how to just pick up and place from your crib sheet immediately. Here, if this is how you have labeled your inductor, current and voltage, now you know how to immediately set in the appropriate either series voltage source or parallel current source in the proper location in your S-domain equivalent circuit. Is that? Now, I had several people ask about convolution, so I thought I would try to talk a little bit about convolution. Or is everyone an expert on convolution? Here I have basically separated out some of the steps of convolution so that I can at least check your work on pieces and not have to have an exact final answer when you might have many different ways of generating the incorrect solution. So here I'm basically saying, can you at least show me that you can flip and slide a waveform? And in this case, both of those pieces belong to one waveform, Z of t. One is not the input, one is not the impulse response. They're both Z of t, and I want you to flip and slide both of those. Or, I'm sorry, Z of t needs to be flipped and slid, and that has two different pieces. And I would do this in all of its glory. I would say, first let me just flip it, and then I'll introduce the shifting or the sliding with t. In this case, flipping just means spin everything around the vertical axis at, in this case, lambda equal to 0, because I want to end up with z of minus lambda, so that I can now eventually come up with z of t minus lambda, where lambda is going to be my variable of integration. Which, if I do that, I hope that you see that this ramp that's going from low to high on z of t at minus 1 is now going to be going in the other direction. And how high do I go? To 3. Oh boy. You can do a better job on your exam. But labels are more important than the sketch, which means where does that point need to be? This needs to be at -2 where I first flatten out, and then I'm at -3. This is now lambda. This is going to be z of minus lambda. And ideally, you would label this amount, but you really need to label it when you get to z of t minus lambda. Maybe you don't have to label it at this intermediate step, but that means you probably want to go back and find what that is here. In this, what's the functional expression for that waveform between -1 and 2 in the original waveform? This is just mx plus b, right? Where x is t, so it's mt plus b. It's going up with a slope of 1, and it's... Is that right? And now what else do we need? We need to make sure that we haven't forgotten this other piece. And it's all the way down at -2 in magnitude. And it has -6 and -8 for its endpoints. And now we just want to put in this variable t in the z expression so that we can slide it from t equal -infinity all the way up to t equal +infinity. Which now says that we can redraw that with, let's say, t a little bit more negative. So this is now t plus 1. This is now t minus 2. And that's t minus 3. And this piece right here is where I need you to label that. Now instead of t plus 1 for z of t, we need z of t minus lambda. So this now becomes z of t minus lambda is now equal to t minus lambda plus 1. And what else do we have? We need to not forget this additional piece, where this is now t minus 6, this is t minus 8, and this has a value of -2. Where are we at? So now z of t minus lambda, what you want to be able to do is check this. So a quick way of checking that might be, let's plug in t equals 0. And at t equals 0, what should you end up with? So up here with this z of minus lambda, what's this functional expression right here? Now instead of z of t, it's z of minus lambda. Everywhere we had a t, we should replace it with minus lambda. So this is now minus lambda plus 1. So now if we plug in t equal to 0 in the final expression, we better end up with what we had for z of minus lambda, which is really z of t minus lambda with t equal to 0. And so that sort of validates our expression for that sloping piece on that z of t minus lambda function. Does that help?
Yeah,
So now that's what you want to sort of get clear in your head with working a few of these. How do I translate from z of t to z of t minus lambda? Now, how could I change this problem to make it a little different, what I could say, let me sort of introduce a new piece to this. So that's answering that question. But let's say that now I've said, okay, problem 6, which it isn't, this problem 6, but let's say that now I introduce an h of t that maybe looks like this. And now let's say that goes up to 2, and it starts at 0. And now I ask the question, when is y of t, for what interval of time is the output with this input for z and the response given by h, what values or ranges on t will y be 0? When it will be 0. So now I want to know, when will the output be 0 for what values or ranges on t? So now can you see that the first, well, the easy parts are, as long as this guy stays to the left of 0, then y of t is 0. Is that clear? So one such value. So now I'm asking, when is y of t equal to 0? That's the question. Or range of t, ranges of t. So now in this first case, I'm saying I need t plus 1 to be less than 0, or as long as t is less than minus 1, y of t is equal to 0. Is that clear? The other easy piece is to say, well, if that piece goes beyond the rightmost side of h of t, then y of t is 0. Does everyone see that? So I'm skipping something, but now this is the first piece. The next piece would be to say, oh, as long as, or when t minus 8 is greater than or equal to 2, or when t is greater than or equal to 10, y of t is equal to 0. Is that clear? Now there was a question. So now the question was, why is it not t less, or t plus 1 less than or equal to 0? I typically like to have my expressions for t maybe closed on the right, so I just have the strict inequality when I'm coming from the left, and then on the right side it's going to be the inequality, the closed. So it's open on the left and closed on the right in terms of my inequalities. It's a continuous waveform, so it shouldn't really matter, but I just, for consistency, usually say, oh, as I'm coming from the left, I'm going to make those my open intervals or times for t. So now I have t less than minus 1. As I slide up, I would now say, oh, when t plus 1 is greater than or equal to 0, then I start having some overlap. It really doesn't matter, but I just, for notational reasons or for consistency, I usually just stick with one of the sides being a closed expression for t and the other one the open. It's not that critical, that piece. But what I want you to see is that I've sort of buried in here another interval of time when y of t could actually be 0. Do you see how that could happen? As I'm sliding z of t minus lambda, as I'm adjusting t, do you see that there's also an overlap pattern where I really don't have overlap between z of t minus lambda and h of t? If you, and here is sort of what I'm suggesting. What's this interval of time? That's 3. It's 3 wide between let's say the left side of z of t minus lambda at t minus 3 and that other piece at t minus 6. I'm basically saying, oh, when I have this picture, I'm not going to have any output y. With this is now t minus 3, and this is t minus 6. So that if I try to account for that, how do I express that? I need t minus 3 greater than 2 and t minus 6 less than or equal to 0. So I need those two to be singing together. From this one, what do we have? T is greater than 5, and this one is t is less than or equal to 6. So that now I know that y of t is equal to 0 for t greater than 5. 5s are wild. T greater than 5 and less than or equal to 6. And so now I have 3 different intervals of time when the output y is 0. And that's a way to just introduce another twist on this convolution. Is that clear? And that's then showing you the open on the left and closed on the right for t. Is the sort of the consistency that I've tried to use. Questions on that? Now, if we go into problem 6 here, so all of that green stuff above 6 is associated with the modified 5 in the earlier exam, and I think this is the exam from the fall of 2013. If we look at 6, this is now saying if I'm convolving x and h to create an output response y, what interval of time t will y now be non-zero? Not 0, but non-zero. Right? So now I'm answering an earlier question. Are we counting? -1. Where did that come from? So the answer was y of t is not equal to 0 when t is greater than -1 and t is less than or equal to 6. And those are really coming from this algebraic combination of the left-hand sides and the right-hand sides. But we can find that by flipping and sliding. We could check our work. Question?
I was going to say, why can't we?
So now the question was, why didn't we flip and slide? How did we just jump to an answer? If you look at where this is coming from this plus that. So this is now 1 minus 2. And this is that plus that, the algebraic combination of those. Meaning, here's one way to think of this. If I was given this system and it has an impulse response of h of t, what does that mean? That means if I hit the system with an impulse, when are you going to start seeing an output for this system? Forget x of t for right now. I now apply an impulse to this system. When will you start to see an output for y? 1. You hit this system with an impulse at 0, And the impulse response says, I don't do anything until I delay 1. And then it starts performing, right? That's what the impulse response tells you. You kick it, and then it shakes, right? You have to wait 1 second before it starts building. When does it stop shaking? At 3. So you hit this with an impulse at 0, and it starts moving 1 second later, and after 3 seconds after you've hit it, it finally stops. Now, if that's the case, when do we actually start hitting this system? At what time for this particular x? We start hitting it at -2. We hit it at -2, when do we expect to see an output? 1 second later, right? So we hit it at -2, we wait 1 second, and at -1, it kicks on. And that's what you just told me. At t greater than -1, it starts performing. Now, when do we stop exciting this system? We shake it from -2 to 3, right? We're shaking it. So we stop shaking it at 3, but what does the impulse response tell us? If we stopped shaking it at 0 with an impulse, it didn't stop shaking until 3. Now we actually stop shaking it at 3. When's it going to quit shaking? 3 seconds later, or 3 units of time later, which is 6. And that's where this is coming from. Now, we did that without flipping and sliding, right? But we could flip and slide and compute exactly the same answer. But now we've done it 2 different ways. The first way was basically add up the leftmost endpoints on h and z, or h and x, and add up the rightmost endpoints on h and x. Or the second approach was, let's think this through. What's h of t saying? You impulse response at 0, it waits a second, and it quits shaking 3 seconds later. And now for this x of t, well, we start shaking it even before 0. We shake it at -2. But we still have to wait a unit of time before we start seeing anything. If we flipped and slid this, which one would you want to flip and slide? I think I'd do H. What? You can do either one, but I would do H because it has less functional changing. Meaning, if I flipped and slid H, I would say, okay, here's H of t minus lambda, and if that messes you up, do it in a couple of steps, but here we would have, well, if we did it in a couple of steps, it would be at -1 and 3, so let's do this. This is now t of -1, and this is t of -3. Is that correct? And now, what do I want to do? Now I want to say, well, this is going to be non-zero when t minus 1 becomes bigger than -2. So when this piece right here starts to move beyond or to the right of -2, I'm going to have a non-zero y of t. And this now says that if I add 1 to both sides, t greater than -1. I hope that's what we had. Then the other piece of this would be, I didn't move z, so it's now, or whatever, x. It was doing something like this, wasn't it? It was at 3. And so I'm now looking to say, y of t is not equal to 0 in what interval of time? As long as t minus 3 is less than or equal to 3. And this now, if I and I hope those are consistent. So we worked that problem 3 different ways with 3 different strategies. Yes? Yes, the question was, can I pattern my equalities and inequalities just the opposite of what I did? And the answer is yes, that's fine. You could say t greater than or equal to minus 1 and t less than 6. If you didn't have an equal sign at all, because what did we learn about y of t, the output? We said it's continuous. So it really doesn't matter if you have that inequality or not. I'm just trying to get you to think about how would this look the best or the sort of the cleanest. So it might be nice to have one being open and one being closed. But as you transition between these different intervals of time where y of t might be different, it's kind of nice to have this open, closed behavior.
So what you're saying is you won't take out.
Oh boy, the question was what I'm saying is I wouldn't take off any points. I would never go that far. I'm always willing to take off points. So, try to be consistent. Okay? So if you establish a convention, try to be consistent with that convention. And I hope it's clear what I'm trying to say now. That if you now had, what do you know is going to be true at time t equal to minus 1? You really know that it's going to be 0, y of t, right? And it's also at t equal minus 1 when you right at that trend. So if you said minus 1 plus epsilon, now y of t is a little something. If you said t is minus 1 minus epsilon, you know it's 0. We're splitting hairs with this discussion. But you're engineers and you need to learn how to split hairs. Right? You may have to argue that. Other questions? Yes?
So I've got a question on like convolution. So it's not homework. Given like 2 impulses, and then it asks us to find like y of t for certain intervals. And so I was wondering, like, I got it. I understood it for what it was like increasing or same, but how do you set up this convolution until
I'm not sure I understand the question, but you're saying, I think, that you might have 2 different impulse responses that you're interested in.
So you have like an x t.
I have to open up a new window. I'm sorry for this. This is making my head hurt. What? It was like 7? I'm not sure what.
It was literally just like 2 like x t, h t, so just like 2 like steps.
So h of t and x, let me see if I can draw this. So you said x of t was a step.
Yeah, so it's just like, yeah, it's like 25.
Is it a pulse or a step?
It looked like a block, but it was literally just like 5.
Is it like that? So this is a pulse, I would say. It starts at some value. Did it start at a non-zero number? Or did it start at 0?
I think one of them started at 0 to 1.
How's that? And you said this is 25. And now what were you wanting H to be?
Oh, like the exact same thing, but time.
And this is 2 to 12? Is that what you,
Yeah.
is that what you would like to see?
So then, like, so when the overlap starts to, say we move H and T, H and T, right? And that overlap is decreased. How do you set up that?
Oh, let me see if I understand. So now let's say, let me do this. I need h of t minus lambda. I need to slide one of these. It would probably be easier to slide the x, but I'll slide h. So now what does this look like? If I flip it across, now I'm just at minus 2 and minus 12. So this is now minus 2 and this is minus 12. And this is now t. Is that okay? So now I think the question, this is lambda. I believe the question was, what happens when I start sliding this, or t minus 2 is now beyond 10. Did they need to be the same width, or did you want them to be different widths? Oh, are you wanting when they first start to change?
So when they first start, so when the overlap first starts, before the first. Right.
This is still x of lambda. Is that okay? And now we have h of t minus lambda, which is 10. This is now t minus 2, and this is t minus 12. Is that looking like something you want? Now what I do when I'm first learning this, I say, let me crosshatch or hash this so that the crosshatch tells me basically my limits of integration. And these are convenient functionally, so it's not hard to integrate. I can still remember how to integrate a constant, luckily. Okay? So now what do we have? When is this overlap pattern valid? So there's two different things that you have to be concerned with. When the overlap pattern is true, what range on t is it? And then what are my limits on my integrals? When is this picture valid? Or, said another way, when I'm sliding t, when is this picture going to change functionally? When would the waveforms not be the same in my overlap? So now I need t minus 2 to be greater than 10, and t minus 12 to be less than 10, and maybe, who knows, maybe it's all mixed up and you say, well, I also need t minus 12 to be bigger than 0. Right? All three of those need to be true. And now you're trying to basically find the ones that are in play. But because these are the same width, these two are going to give you the same answer. But that's okay. You didn't know that, let's say, going in. Meaning, now I have this overlap picture is valid when solving for this or that. I get t is greater than 12, and solving this one, it's t is less than or equal to 22, right? So now I have t is bigger than 12 and less than or equal to 22. And what's y of t? My arguments here, I have a 10 and I have a 25. That's as confusing as it gets. for this, right? Those are my functional descriptions for x and whatever. Did I flip and slide h? Oh, yes. I didn't hear that question. The question was, I would like to have to integrate constants. So that might be a reason why I might say set up the expressions, so that you have to now set up these, let's say, quadratics and cubics. Well, maybe I'll do something other than polynomials. Maybe I'll do something with cosines. Anyway, you would then have to just put in the expression, the functional expression that's true, and then now what are my limits of integration? Now I'm looking at finding where do I have both blue and red hashing together, in what interval. So my lower limit is, what's my upper limit? And that's true for t between 12 and 22, and 12 and 22 are not the same as t minus 12 and 10. That's why I say you have intervals and limits, and we need to flip and slide. So I'm distinguishing between the interval, when this is true, and the limits on your integrals that you need to use to compute that. Questions on that? Is that what you were looking for? Other questions? No? Are you ready to go? Are you ready for the exam? Yes, question?
So the other interval for this one has zero to us.
So now what are the limits, or this one I actually slid all the way up, didn't I? When is this going to be 0? When will we quit having a response? When will y of t become 0? When t minus 12 exceeds 10. So when t is bigger than 22, we're going to be off for y. I think you're saying, what if I went back before this? Is that true? So now, if we wanted to look at, so I'm sort of doing this in reverse, because I thought that's where you wanted me to push the h. But now if we had, this was x, and now I think the question is, what if we had this piece? Is that where I was at? And this is now t minus 12. So that now I have this, and I have this, but this is now I have to break this up into two pieces, right? I need to find the interval of time when this overlap picture is valid, and I need to find the integral expression that y of t is equal to. Meaning, when is this overlap valid? What are my limits on t? Yes, question? So, did everyone understand the question? This is because of the uniqueness of this problem. My x is the same non-zero interval width as my h. The question was, what happens when they exactly align? Well, because y is continuous, it really doesn't matter. You don't need to consider that as an additional case. So we really have no overlap when t minus 2 is less than 0. Then this picture of overlap becomes in play, and that's true when t minus 2 greater than 0 and t minus 2 is less than or equal 10, or Maybe you can't see it and you say, or t minus 12 is less than or equal to 0, right? If they're different widths, one of those is going to come into play before the other one. Is that clear? But now that they are the same width, that intermediate exact overlap is immaterial because it's covered by both overlap patterns. But this one now says that as long as t is less than 2, t is greater than 2 and less than or equal to 12, we have this overlap picture. And what's y of t? The hard piece is to integrate. Not, because these are constants, right? 10 and 25 d lambda. So we have 250 d lambda. That's pretty straightforward, I hope. If you can't integrate that, don't tell them that you had any math with me. What are my limits? When is this? What's the lower limit? And now I'm looking at the crosshatch. Is that clear? And if you looked at this, if you evaluated this right at 12, that's when this one should be true and this one should be true. And so why do we need to do the middle one, really? And that's why we have the greater than or equal to signs, is so that we sort of transition from one case to the other smoothly. One is holding when we're in case 2, and the other one's holding when we're in case 3. Just so we don't have to say, well, I don't know, it says it's true for both. Well, it is. Yes?
So we define, like our typical open, YFT, like YFT valid, separation of YFT. Stuff like, but it doesn't really matter, like, side is like.
Correct. So we just need to find the expression for y of t, and now I just want you to be consistent with how you assign your open and closed intervals on t. I'm not sure if that's what you asked, but I tried to rephrase it. Is that clear? You need to know how to do transfer functions. You need to know how to evaluate those at given frequencies or different frequencies. Be good? I'm going to shut it down. Good luck.